Alright, so I'm here to do number 11 in the extra credit packet or extra practice packet. And number 11 titles in triangle ABC, find the length of the altitude from A to BC. And point A equals 5, -1. Point B equals 1, 1. And point C equals 5, -1. Or -11, actually. Sorry about that. And it says find the point, or find the length of the altitude from point A. Let me draw that. From point A to line segment BC. Right here. In order to do that, first step is you need to find the slope of BC using slope formula, which is y2 minus y1 all over x2 minus x1. Alright, so plug in certain numbers. Alright, so 1 plus 11, because double negative is a positive, and all over 1 minus 5. 1 minus 5 goes to -4. 1 plus 11 goes to 12. Comes out as 12 over 4. -12 over 4 simplified to -1 over 3 is a slope for BC. Alright. And since A, or wherever the name of the altitude is forms a 90-degree angle, which means it's perpendicular. Perpendicular lines have opposite reciprocal slopes, which means the slope of this altitude is opposite reciprocal of the slope of BC, which is -1/3, which means the slope of this altitude is 3 over 1. Using that slope, we can find this point right here, and using that point, alright, so 3 over 1, so down 1 over 3 in reverse instead of going up. That gives you point 2, -2 is the point where it intercepts BC. Using that, you can find the length, or distance more so, of that altitude. Using the slope formula, which is D equals y2 y1 squared plus x2 minus x1 squared. There, distance formula. Plug it in for our equation. Comes out to be -1 plus 2 squared plus 5 minus 2, so x is squared, all radical. -1 plus 2 comes out to 1 squared. 5 minus 2 comes out to 3 squared. Square root of everything. 1 plus 9, still under radical for everything. So radical 10. D equals radical 10. Means the length of the altitude also equals radical 10. Done.